Hi guys. Today we're continuing with simplifying rational expressions. Today, however, we will not be working with monomials. We will be working with polynomials. That means that there will be adding and subtracting within your fraction. And that also means that we're going to be factoring today. So take out your factoring book, or if you didn't make a factoring book, you want to take out your factoring notes. You have to be able to factor to be successful in today's lesson. Let's get started. So this says example 2 because it's a continuation from yesterday's notes. You can ignore that it says example 2. This is our first example for today. In this example, I have a fraction with two trinomials, one on top and one on the bottom. Now, when you have an adding or subtracting problem, you cannot just cancel out the pieces of it. You can only cancel out parts of a multiplication problem. And so if you ever see adding or subtracting inside of a fraction, your first thought, the first thing that comes to your mind needs to be, I have to factor. Factor first. Look, I wrote it in red, it's bold, it's all caps. This is the most important part of this chapter. This is what's going to make you successful. If you remember to factor first, you're going to pass. It's that simple. You have to factor. So we're going to factor first. We will need to factor twice in this problem because we'll have to factor the top and then completely separately we'll factor the bottom. So let's start with the top. The top is a trinomial, and to factor a trinomial, we do xbox. So we need to think of two numbers that multiply to make -8 and then add to make a +2. The number that's negative, it does matter. You are going to have one negative and one positive. That's how you multiply to make a -8. And so in this problem, we want a +4 and a -2. 4 times -2 is -8, and 4 minus 2 is +2. Now this one does not have a leading coefficient. There's not a number in front of the x squared. So I can go straight to my parentheses. So one of my parentheses will have an x plus 4, and the other one will have an x minus 2. Now we're going to start over again, and we're going to do the bottom. So for the bottom, we also have a trinomial, so that one is xbox again. And on this one, I need two numbers that multiply to make a +6 and that add to make a -5. And so my two numbers, to make a +6, they have to be the same sign. And to make a -5, they have to both be negative. So in this problem, I want a -3 and a -2. And again, since there's no number in front of my x squared, I can go straight to my parentheses. One of them will have a -3 and the other one will have a -2. Okay, so factor first. Once you're done factoring, you should notice that there are two parentheses, one on the top and one on the bottom, that are 100% exactly the same. Same variables, same numbers, same symbols, in the same order, like all of it, everything is the same. And so if you notice, and this should happen because this is kind of the whole point of these problems, is to cancel something out. So when you notice that there are two parentheses that are 100% exactly the same, then you can cancel those out. Now, when you're canceling out the parentheses, you're canceling out the whole thing. We're canceling out the x minus 2 with the x minus 2. Please notice I slashed all the way through the parentheses. I didn't cross off the x's and then cross off the 2's. It's not how it works. It's all or nothing. You cross off the whole parentheses or you don't cross it off at all, which is why we're not allowed to cross off the x's from my other parentheses. So it's the whole thing or none of it. Whatever you have left over is your final answer. If it helps you, you can leave it in the parentheses so that you're not tempted to like cross off the letter X. Or you don't, the parentheses in this problem are not necessary since you only have one of each on the top and the bottom. So the final answer for this problem is x plus 4 over x minus 3. And I kept my parentheses on, again, just to give me that visual of, you know what, I can't cancel anything else out. This is my final answer. Let's do one more together just to make sure we fully understand how to do these problems. Okay, so here I have another fraction. On the top and bottom, I do have adding or subtracting. It's subtracting for both of them this time. And so my first instinct when I see adding or subtracting is I got to factor. I have to factor this. I got to factor it right now. So these are both binomials. That means no Xbox for this problem. And the first thing I'm supposed to check for is a GCF. And these both do have a GCF. Now you're checking them individually. So looking at just the top, 12 and 4 are both divisible by 4. So I'm going to factor out a 4 from the top. And then when we factor the bottom, it can be something totally different. Like everything gets factored individually. So on the bottom, I notice that I have 2 and 18. Those are both even. So I'm going to factor out a GCF of 2. Now, on the bottom, I have an exponent still on my variable, which means I might be able to factor it again. So on the bottom, it's x squared minus 9, and that's a binomial. And the only other way to factor a binomial is difference of squares. So that is a difference of squares because I know the square root of x squared, I know the square root of 9, and it's being subtracted. When you factor a difference of squares, you get 2 parentheses. You're going to square root both terms, and you'll put one with a plus in the middle and one with a minus in the middle. And it doesn't matter what order you put them in. So now I have factored the top and bottom completely. I have factored them. I can't factor them anymore. But I'm noticing that, not too many things are going to cancel. Nothing looks exactly the same. I have 2 parentheses that are almost the same, right? I've got this 3 minus x on top. I've got this x minus 3 on the bottom. So those are very similar, right? They both have x. They both have 3. They're both a subtraction problem. The issue is, though, they're not in the same order. And in a subtracting problem, order does matter. So the fact that they're not in the same order, that's an issue. If I have a subtracting problem that is in the wrong order, or it's in the order I don't want it to be in, I can switch the order. I can't just switch it because I want to. But if I factor out a negative, then I can switch the order around. Because if I factor out a negative, it'll make this 3 a negative 3, and it will make this x a positive x. And that's what we have down here, a positive x and a negative 3. So if I make this 4 on the outside a negative 4 instead, then I can flip-flop my subtracting problem. And now they're the same. Okay, so if you have a subtraction problem that's in the wrong order, take out a negative sign, factor it out to the front, and then you can switch the order around. If you have an adding problem that's out of order, just switch the order because the order on adding problems don't matter. So just change it. But on a subtracting problem, you do have to actually do a little math to switch it. All right, we're ready to cancel, and we very specifically made it so that we can cancel out the x minus 3's. So I'm going to cancel this out. There's no other parentheses, so I can't cancel out the x plus 3, but I do have some outside numbers. I have some numbers that are not trapped or confined within a parentheses. So if you have outside numbers that are not trapped or confined within a parentheses, then those numbers you can also simplify. And those numbers you're going to simplify like we did yesterday. So I'm going to look and say, hey, I have a 4 and a 2. 4 is divisible by 2, so I can simplify that. Now, again, you can only do that if it's not within a parentheses. It has to be a GCF that you factored out to the front, or it has to be part of a monomial, not part of a polynomial. For my final answer, I have a negative 2 on top of my fraction, and I have an x plus 3 on the bottom of the fraction. Okay, so big takeaways from today: factor first, and then when you're canceling out parentheses, they have to look exactly the same for you to be able to cancel them out. Now, we will practice this a little bit more in our live session today, so I will see you there.